So thank you for coming to this panel. The panel is titled Blockchain Deathmatch, Permissionless versus Permissioned Blockchain. And let me first tell you the difference between permissionless and permissioned blockchain. And then we're going to have our panelists that are going to discuss very intensively about the different worlds. So permissionless blockchain is your favorite cryptocurrencies. Bitcoin, Ethereum, and all your other cryptocurrencies are all permissionless blockchain. What it means that anyone can have the rights to read, audit, write the ledger. Permissioned blockchain, instead, are blockchain where only selected few, usually people that are part of consortium, firms that are forming consortium, can access, read, write, and audit the ledger. And so today we're going to spend about 45 minutes talking about permission versus permissionless blockchain. And then we're going to open it up to the audience. If you want to submit your question, please do it at slido.com. And we'll take 15 minutes of questions. So let me first introduce you our three panelists. On the left corner, we're going to have Chris Ferris. Chris is an IBM Distinguished Engineer and CTO Open Technology for IBM. Chris has been involved in the architecture, design, and engineering of distributed systems for more than 40 years, and has been actively engaged in open standards and open source development ever since. He has technical responsibility for all IBM strategic open source and standard initiatives, including Hyperledger, Open Container Initiative, Cloud Native Computing Foundation, OpenStack, Cloud Foundry, Node.js, and Docker. He represents Hyperledger. He represents IBM on the Hyperledger Governing Board. He's a maintainer of the Hyperledger Fabric project and member of the Hyperledger Technical Steering Committee. In the center, we're going to have Angela Welch. Angela is a professor at St. Mary's University School of Law in San Antonio, Texas. And she's also a research fellow at the Center for Blockchain Technologies at the University College London. Her research focuses on money and law, cryptocurrencies, and blockchain technologies. Angela's work is internationally recognized, and she speaks at events around the world. She's best known for her theory that key software developers of public blockchain function as fiduciaries to those who rely on the systems. And in the right corner, we're going to have Jimmy Song. Jimmy is a Bitcoin Core contributor and venture partner at Blockchain Capital. He started working on open source crypto projects in 2013, contributing to Bitcoin Dark, Armory, PyCoin, and Bitcoin. Jimmy Song also runs a very popular worldwide 2-day Bitcoin seminar for developers titled Blockchain Programming Course. And he also teaches that class at the University of Texas at Austin. He has over 150,000 followers in his YouTube and Twitter accounts. And welcome, Jimmy Song. All right, so my first question is about what is blockchain technology? Because it feels to me that there are a lot of disagreement about what blockchain is or is not, especially when it comes to permissionless versus permissioned. Many critics argue that a permissioned blockchain is not really a decentralized database or ledger. And so I'm going to start with you, Chris. You have witnessed the evolution of distributed systems and decentralized systems for many, many years.
Sure.
So my question is, what is a blockchain for you, and why you think that a permissioned blockchain is a decentralized database?
Sure. So, at its essence, a blockchain is an ordered, append-only transaction log where the transactions are ordered into blocks, and each block is essentially cryptographically bound to the one preceding it. So essentially, it creates a tamper-proof record of a set of transactions. And the order of the transactions and the blocks is determined through consensus. Now, again, when we get into the distinction between permissionless and permissioned blockchains, there's different approaches to how those various systems achieve consensus. It's a subject that's been studied for decades, really, and has been applied in a number of sort of distributed database type problems. The way that I sort of look at permission blockchain is that it's an evolution of distributed databases, but one that adds a layer of trust.
So when it comes to like consensus, can you be clear about how a permissioned blockchain achieves consensus in a decentralized way?
Certainly. So in a permissionless blockchain, typically the consensus is established through proof of work. And I'll let Jimmy describe what proof of work is. He does a very elegant job of that. But in permission blockchain, and again, we have to get into what does permission mean. But in a permission blockchain, because there's a certain degree of trust established at the point where you're permissioning, where you're essentially voting people onto the island to let them participate in your blockchain network, and you know who they are, you can establish certain levels of trust and certain levels of governance over that assemblage of individuals into a consortium, whatever you want to call it. And as a result, you can sort of, because of that additional trust, you don't necessarily, I'm not saying in all cases, but you don't necessarily in many cases have to deal with true Byzantine fault-tolerant type consensus, and you can leverage more traditional forms of consensus like Raft and Paxos and so forth.
Jimmy, do you have any different opinion on the topic?
Well, I mean, to a large degree, when I think about something like a permissioned blockchain, I see those two words as an oxymoron. Like, why do you need permission if it's supposed to be decentralized? Like, what does it mean for somebody to give you permission to be able to write into a database? And that in itself, like, there has to be an entity that's giving you permission, and that by nature is, of course, centralized. I would characterize maybe what we're talking about here as more like a federated system, and that's maybe different than a completely centralized system, but it's certainly not decentralized in any reasonable way. It's the power is spread among maybe slightly more people, more organizations, something like that. But it's not really decentralized in that way. And the beauty of something like Bitcoin, and I will take a little bit of an exception to what you said, Cesare.
Okay, please.
When you said that, when we're talking about permissionless blockchains, we're talking about Bitcoin, Ethereum, et cetera. I think Ethereum is a permissioned blockchain. Because
I didn't say Ethereum, actually.
No, I mean, Cesare did. So when I think about something like Ethereum, and Vitalik decides that, okay, well, these particular transactions are not good for the Ethereum ecosystem, so we're going to roll them back. That happens, right? That's exactly what happened with the DAO. He decided, okay, well, these are not transactions that should go in our blockchain, so therefore it's not. So in that sense, that one is also a permissioned blockchain. To me, the only permissionless blockchain that exists is the one that's actually decentralized, and that is Bitcoin. Everything else is really just a form of some sort of centralized database, and to me, it doesn't really make sense to call it a blockchain even, because it's not really. It's a particular type of centralized database.
But do you disagree with the notion of exactly what a blockchain is? I mean, the way I described it, right? It's a collection of transactions that are ordered into blocks, achieved through consensus, cryptographically bound to the previous one, so that it becomes essentially a tamper-proof audit log of the transaction.
Well, I mean, it depends what you mean by tamper-proof, because if one entity controls that database, then they can sort of like change stuff over later.
Okay, right.
If you download it, and then, yeah, you can prove otherwise.
Totally.
Yeah.
Totally. But, okay, but that said, right, in the context of something like, okay, so I work on Hyperledger Fabric, and Hyperledger Fabric essentially has decomposed the notion of what we have. We have an ordering service, and then you have the peer nodes. And rather than the peer nodes each doing, the equivalent of executing the transaction, repeating it, validating it with the ones before it, Essentially, we have an ordering service that does that, and that can be truly decentralized, right? You can
wait, the ordering service is very centralized
No,
from what I understand, because there's one ordering
be,
service that decides on what the order of the transactions are.
No, let's be clear. The ordering service can be decentralized in terms of what authorities are operating a given node of the ordering service.
But everyone needs to go and ask the ordering service what the order of the transactions are, correct?
The ordering service is yes, but again, it's a decentralized system.
How is it decentralized if everyone has to go and ask that ordering service what's going on? That's the definition of centralization. If you have to go and ask somebody what order was this transaction in, that's a centralized service.
But the ordering service in Bitcoin is exactly the same.
No, it's used by proof of work, and anyone can create it. Right? Like proof of work means that as long as the ordering meets the consensus rules, anyone can do it, right? You can be somebody in China, you can be somebody in Malaysia, you can be in Africa. Doesn't matter. There's no permission involved.
Right, but Jimmy, the whole point of a permission blockchain essentially is to establish a set of trust amongst the participants.
And that's why I'm saying it's really not anything that's decentralized, because if you have to establish trust or have governance, then that by itself means that there's some central entity that's in control of it.
No, there's a central piece of software that's shared by a number of entities that are operating a copy of that, and they're each operating it independently of one another.
Except they have to go and ask the ordering service,
And it's using a traditional or more traditional fault tolerance to achieve consensus as to which is the leader at any given point in time.
Well,
so if you tell me that's not decentralized,
it's not, because it's not Byzantine fault tolerant, right? Like you have an ordering service that everyone is asking.
Jimmy,
what is the order?
It absolutely can be Byzantine fault tolerant.
No, because you have a single entity that tells everybody what to do. If that entity is hacked or lied to, then it's basically everyone gets false data, right? Like if the ordering service is hacked, right? Whoever is controlling the ordering service is hacked, and they go, okay, well, it wasn't this transaction, it was this other transaction. If somebody's doing a double spend, well then, you can fool somebody, right? Like that's the entire idea. The ordering service is a central point of failure. When I say centralized or decentralized, we might need some sort of definition here. Here's what I mean. It's centralized if there's a single point of failure. And I say that because that is exactly how governments control things, right? If there's an authority or somebody, if I am the US government, if I am a dictator, if I am somebody that wants to control something, typically what happens is they go, okay, you know what? I am going to choke this, I'm going to regulate this single point of failure. I'm going to say, you need to comply with these regulations. You need this license, you need this, you need that, in order for you to run this thing.
Right.
That's exactly what that ordering service is. That can easily get regulated, choked out. It's not decentralized by that definition because it's a single point of failure. Whereas with Bitcoin, there is no single point of failure.
Okay, so that's where I beg to differ here.
Angela, please.
I think you're both overstating the decentralization of your respective systems. So Bitcoin, you point, first of all, to Ethereum and the DAO, and I absolutely agree with you that that was an exercise of something that was arguably centralized power, that decision. I am struggling with how Bitcoin doesn't have a similar centralization of power in the core developers. And I say that I'm looking for your reaction to what happened with the recent bug back in September and how that was resolved, right? So my understanding, based on the report that was issued by the core devs, is that someone reported a bug to a very small group of people, 3 or 4 people, the core devs, and they recognized, oh, this is a real bug, so let's look at it, figure out what to do. Oh, it's actually a much more serious bug than we originally thought. It's an inflation bug, to where, I'm not as technical as you guys, but an inflation bug would mean that many, many more Bitcoin could possibly be created, okay? Changing the 21 million cap. Right? So when they found that, they're like, okay, we got to get a few more people roped in here. They list a total of, I believe, 11 people who knew about this. Those people made a decision about how to fix this, but they also decided in the patch that they were issuing to the world to say, this is just for the first, more minor bug. We're gonna hide the fix for the inflation bug in here, but we're not going to tell people that that's what it's about, okay? They made a lot of decisions for a lot of people in the world. Like, this is multi-billion-dollar systems. They told a few select miners at the beginning. The miners, I think they listed Slush Pool as the one they told first. That miner was given privileged knowledge of this to get the upgrade going very quickly. That, to me, is power exercised by a very small number of people over all the people relying on the system. I'm curious about how you...
Okay, all right. So first of all, let me just tell you about the bug. This is CVE 2018-10369, something like that. I forget the exact number. But basically, it was a bug that could only get executed by a miner. It could not be executed by anybody else. And that's why they had to, just using the rules of responsible disclosure, they exposed it to the miners first. And it wasn't just Slush Pool. They told other mining pools, hey, you know what, like, here's a bug. Please make sure that you don't mine a particular transaction. It had to be a transaction that spent the same input twice in the same transaction, because it would cause an assert zero, and it would be an inflation. It would cause an assert zero on main clients, but it would get into the blockchain on a miner. So it would cause a show-stopping bug. It would basically take down any node that hadn't upgraded, essentially. So it was more a responsible disclosure kind of thing. But that said, that was only one software. Bitcoin Core is not the only software out there for Bitcoin. There is BTCD, also another thing, Cesare. It's not Bitcoin Dark, it's okay. BTCD, which is another implementation of Bitcoin software. There's Bcoin, there's LibBitcoin, there's a bunch of other software that's also running on the network at the same time. All of those did not have that same bug.
Okay.
And so it would have been out of consensus if you had that. So it would have actually started to stall, and you would have had a large fork. And part of the responsible disclosure was to make sure that that didn't happen.
Yes. I'm not arguing that's not responsible disclosure practice. I'm sure that it is when you have a system that's that important. What I'm saying is the way that they resolved it demonstrated that these people were exercising power and a centralized power source.
Centralized authority.
They were a centralized authority making decisions about how to resolve this, when to disclose it, who to disclose it to.
Well, I mean, it's one piece of software among an ecosystem of software, right? Like this is Bitcoin Core versus BTC.
What is the percent of the system that runs Bitcoin Core, though? 90 plus?
Yeah, something like that. But I mean, the number doesn't necessarily mean that that's like what everyone runs, or I mean, like that's the economic majority. Most large companies run multiple nodes, right? Like they'll run BTCD, they'll run Bitcoin Core. They'll make sure that they're all in consensus, so that if you have some sort of work or consensus problem, that they'll know right away. And that's part of good practice. If you are a business, you don't want to lose money on some sort of weird bug or something like that. So, I mean, like the way you're characterizing it is core devs exercise power by fixing a bug that would have been out of consensus with all the other software. I see it as they were fixing a bug so that they would stay in consensus and not cause an inflation. Because all the other software actually didn't have this bug.
No, but so I think, so there was a recent blog post by Bruce Schneier. He actually gave a talk at the Hyperledger Global Forum last fall. And he wrote that up as a blog post, where he basically talks about the notion of trust and blockchain, right? And he highlighted the fact that, in fact, permissionless blockchains, in particular, he mentioned Bitcoin, but he also, I think, Ethereum, did not necessarily solve the problem of trust. They don't, I mean, yes, you can sort of trust the math, right? But there's still a number of aspects of the system that you have to trust, and that would
What aspects do you have to trust?
You have to trust the core developers are going to do that.
It's open source software. You can go and look at it.
You have to trust that the miners aren't going to collude amongst themselves.
Okay.
Right?
No, but that's a very different thing than a centralized system. That's not a single point.
You still have to that trust. You have to trust that. Is my point.
No, you don't have to trust the miners, right? Like if I wanted to, if they started mining only empty blocks or something like that that would attack the network, I, as a full node operator, can say disconnect block on the first of their blocks that's empty. That's something that every node operator has the right to do. And as a decentralized system, if enough people did that, then the chain that those miners went along with, even if they had 90% of the network, would no longer really be Bitcoin, right? Like it would be, the economic majority would be somewhere else. I mean, what the miners do is they secure the network, and that's something different than a single point of failure. And if they decide to go off on their own and try to throw a coup, then Bitcoin would go and use the security of somebody else. They most certainly are a single point of failure,
because if they did fork the network that way, then you end up with the system that's broken.
No, it's not broken, because you still have Bitcoin. Bitcoin still survives. It's not a single point of failure, right? Whereas Hyperledger, if you do take over the ordering service, then you control the system, because you get to say which transactions come first. And that means that if you have a double spend, you get to decide which one is legit and which one
Who does decide that? Can you explain that a little more to us?
So the ordering service is a distributed component. You can have multiple ordering service nodes that collaborate through consensus to decide what the who the leader is. Who
controls the nodes in the within the ordering service?
It depends on the nature of consensus that you're using. Right now we're using Kafka as the consensus giver, essentially, in that, and that's just essentially distributing.
But how can you give consensus?
It's just doing leader election. Hold on, let me finish my point here. and we're implementing Raft in this next release. That's coming out at the end of this month. Following on that, we're using SBFT simplified and both smart and simplified Byzantine fault-tolerant consensus for the ordering system. Raft allows you to have ordering nodes run by independent organizations. So if you have a consortium of banks, for instance, each bank could operate an ordering node, and they choose through consensus the order of the blocks, right? And this isn't hard. It's not a central point of failure, because you can even have different versions of the software running at each of those different nodes, and they're still operating together collectively to form consensus on the order of the transactions. So don't tell me it's not decentralized.
It's not decentralized because you still have a service, right? Like you have this thing, and you still have leader election and things like that, which are completely different than like proof of work. Proof of work is an objective metric. Leader election is a very political process. And you could, as a result of that, and say, okay, you know what? We're always going to. The U.S. government mandates that Bank of America is always going to be the leader of the ordering selection, and the NSA is going to decide for the Bank of America exactly what ordering of the transactions, because we think some of these transactions are bad and they're against our political enemies, so therefore we're not going to allow them.
You're arguing for anarchy over any kind of regulatory?
Well, I mean, I'm just saying it's a central point of failure. It's a single choke point. It's somewhere somebody can come in and control things.
Yeah, but
that's very different than something like Bitcoin, which does not have a single point of failure.
But let's examine some of this. So there have been hard forks, right, obviously. And so in that situation, you have to choose which side you're going to go with, right?
Yep.
Yes, no.
Yeah.
Correct. Okay. So,
and it's not some central entity that chooses. It is the people that chose. It is the economic majority that chose.
Right, and then you have the majority chose for leave and Brexit, and obviously that was the wrong answer for I think a lot of.
I mean that's a whole different system of democracy.
My point is, it's an uninformed decision. How do you make the right decision on which side to go?
I mean, it's decided by the economic majority. That's a very different thing than a single point of failure where a government official can say, you are going to do this.
So the guy with all the money wins? Is that what you're saying?
No, it's the economic majority that gets to decide. That's a very different thing than a single point of failure. Again, single point of failure
economic majority
is centralized. Non-single point of failure is decentralized. That's what we've been arguing about this whole time. And a permissioned blockchain is an oxymoron because it is a centralized database that's masquerading as something that's decentralized. And I've said this before, blockchain to a large degree is a buzzword for that reason. It's being used by a lot of people to mean something that it's not, when really you can do a lot better as a centralized database with a single, you're going to have a single point of failure anyway. You might as well run an Oracle database and have all, like not have all of this complication around it and run it a lot more efficiently. And in fact, if there's anything that is useful out of quote unquote permission blockchains that come out of this, then that is exactly what's going to eat your lunch, is because anybody that does it in a centralized way with their own database that's a lot more efficient, they're going to be able to do it at 100 times less cost than something that is a permissioned blockchain will. So, I mean, that's my analysis of it. And this is something that I've studied for many years.
I think it's flawed. I think so you could take like QLDB, right? Take the quantum database that Amazon recently announced. That's a centralized database. And the fact that it has a blockchain pooping out the back end of the transaction log essentially tells you know what went in. But you don't know that they can't go in there and actually hack the system so that what's reflected back to you when you do queries against the thing doesn't actually match what's in the transaction log. You'd have to go back and actually do validation of every single transaction to ensure that, right?
Yeah.
So, but that's totally inefficient, right? As opposed to having a system where you have that information replicated.
I agree that a centralized system is way more efficient.
Everybody is participating in that consensus process. People, all those nodes are or some of the nodes in the Hyperledger Fabric case are participating in endorsement of those transactions to enable it to get much better throughput, much better, transaction processing throughput than you could possibly achieve with a system like Bitcoin.
No, but you can achieve way better throughput with a centralized database, and you already have a single point of failure. So what's the point of doing, like putting all this scaffolding around it that's not really adding anything? I mean, you're already centralized. You already have a single point of failure. So why wouldn't you make it go further down that way to make it more efficient and at least save money for your customers? Because at this point, when you're adding all of this machinery, like blockchain is a combination of a lot of different technology, public key cryptography, proof of work, and Merkle trees, and like networking, and all this other stuff. And when you combine it in that particular way, it works for Bitcoin because it is a monetary medium, and monetary mediums work much better when they don't get to change. Almost everything else works a lot better when they do change, when you iterate. This is what every startup has to go through, is you have to iterate, change things, try things again. Right. You can't get it all right the first time, so you try to find product market fit. And this is my problem with almost every ICO, with almost every blockchain project, which is that they think they have the solution at the very beginning and that they can't really upgrade. I mean, if you're quote unquote decentralized, you can't really force anyone to upgrade. So in a sense, what you're arguing for is an inefficient system being somehow efficient. And that doesn't make any sense to me, because what you're saying is we need quote unquote decentralization even though we have a single point of failure.
So I don't know, I've been doing this for like 40 years, as Cesar said. And we've been working on doing distributed, decentralized computing for quite some time. Both at IBM and many companies that I worked at prior to that. My point is this: we're not necessarily trying to build Bitcoin 3.0 or another Bitcoin. In fact, the purpose of permissioned blockchain is essentially to enable enterprises, to enable business to achieve the ability to share information in a reliable, trusted manner that preserves privacy. Bitcoin permissionless blockchains don't do that at all. Okay. At scales that many enterprises require in order to share that information, but without having a centralized database that's owned and managed by a centralized authority. Yeah, so when I talk about decentralization of the ordering service, I'm talking about decentralizing the authority of operation of that service, right? And then using protocol as a means of preserving the consensus amongst those.
Okay, all right. So what you just described is two parties that want to share information in some private way. That does not require a blockchain.
Right? I didn't say that it did, but I'm not saying it's necessarily two parties. It could be 5. It could be 50.
And again, you don't need a blockchain for that either.
Well, okay.
So let me intervene 1 second. So first of all, now you understand why I call the panel Deathmatch. And And second, it seems to me that the distinction is that, for you, Jimmy, decentralization or centralization is like a 0-1. Either you're centralized or you're decentralized.
Yes.
It seems to me, and correct me if I'm wrong, Chris and Angela, for you it's more like a spectrum of like, well, they can be fully decentralized, but there is also a spectrum in between them, and companies for business application choose the right level of centralization or decentralization depending on their needs.
I think that's a good description.
I'm not even sure we get all the way to full decentralization, but it is a spectrum.
Yeah.
It's not a 1-0, but it's more like a spectrum.
Yeah.
And so
it's quantum.
So would it be correct to say that permissioned blockchain are less decentralized than Bitcoin?
Yes.
Okay.
But that's because, again, in the context of a permission blockchain, typically you're going to be doing something like forming some sort of a consortium of parties that are going to collaborate. So they know everybody that's in that blockchain. But that's intentional, right? In the context of Bitcoin, Ethereum, some of the other permissionless blockchains, by definition, everybody is anonymous. You don't know who the other guys are, and you can't possibly trust any of them, right? In the context of a permission blockchain, though, if I decided that I wanted to get, all of my banking colleagues together, I'm JP Morgan, I'm Citigroup, I'm Bank of America, whatever it is, and form a blockchain consortium, we could do that. We know each of us is going to operate a set of nodes in that configuration. We know who's operating any given node. We know, so we can identify through the certificates that are used in that system who's who, right? We can put a governance model over that and a legal framework around that says essentially, look, if you do something to try and disrupt this system, we'll sue the pants off you, and you'll regret that, right? But again, that to a certain degree, it's centralized to the sense that there is a governance model around that, all right? It could be regulated, right? There could be regulators participating in that system, right? Directly. But again, you know who they are, and so my point is this: it isn't truly decentralized in the total anarchic, God only knows who's running the thing. Instead, we're taking advantage of the additional trust that you can add with a governance layer, with the legal framework around the system, with identity of who's who in that system, and we can achieve more efficient means of achieving consensus than you can with proof of work. And that's essentially at its essence, that's what we're trying to accomplish.
Yeah, and what you're describing is parties that can identify each other and do business together.
Yep.
That's fine. But again, that's centralized, right? Like,
can we say it's less?
It's less.
No. I think it's a 1 or a 0, right? Like it's either you can get regulated, and in which case they can tell you exactly what you need to do.
Okay,
and they can impose whatever they want into your system. In which case you've basically ceded control to somebody else.
Right. No.
You are either self-sovereign or you are not. With Bitcoin, you are self-sovereign. With a half-assed decentralization, you do not have self-sovereignty. And that's a very big difference. And also, you also said something that I want to disagree with. You said you can't trust anybody on the Bitcoin blockchain. You can't possibly identify someone. That's not true. You can sign with your address. You can sign with your public key or private key and prove that you are the person on the other end. That's actually how people do peer-to-peer transactions. That's how you do Lightning transactions. That's how you're supposed to do transactions, is by proving to them instead of verifying, not trusting, and like being able to do that. Once you can verify, then of course you can trust that the other person is who they say.
Identity is just that. It's just a sort of it's an identifier. It's not an identity.
Yeah.
That's right. It's not. So you have a key that says I'm transacting with that key, but I don't know that I'm transacting with Angela. I'm just transacting with a key, right? Am I correct?
Yeah, I mean, same thing with IBM, right? It's who they say they are, but you don't know. It could be a hacker in the middle that has the IBM, controls the IBM node, right? Like that's
the point that I want to take issue with what you just said is it's not self-sovereign. And on that point, I would say, yeah, you're right. Okay? But you're also making an argument that you can't be, you can't be regulated. Well, I think you probably will be at some point. But
Well, they could try, but I'm still self-sovereign over my Bitcoin.
okay, or they could basically regulate it so that nobody can use that.
No. Well, I mean, they could try, but
Okay.
it's. I mean, they tried that in China, right? Like they took away every exchange. They took away local Bitcoins. Well, guess what people are doing? They're trading Bitcoins over WeChat and Telegram.
Yeah.
Right? Like you could try to regulate that away, but it's decentralized. You
Right.
are sovereign
But
over your own coins.
you're making
so
an
you
argument,
can do that.
Right.
With Hyperledger, if a regulator says you IBM are doing something bad, we think you are trafficking drug money, then they can shut you down. You are not sovereign over
And
whatever
that's
assets
a
you have over
problem because
Hyperledger. That is not self-sovereignty. That is not decentralization. You are not in control over your own data or whatever it is that you have. That is the difference between centralized and decentralized. You either have control over your own stuff or you don't.
But you are
It's a 0 or a 1. That's
have
it.
Either anarchy or you have.
So I think the discussion is really about, like, do you believe there is a spectrum of centralization, decentralization?
Right, but I don't agree that it's
versus
Rule of law
But
and
I would like to actually follow up with Angela.
You're speaking of regulation and governance frameworks as if it's a bad thing. And in fact,
Oftentimes it is, yeah.
philosophy.
So I would like to
tell that to every business on the planet. Just tell it to them.
I would like to pivot a little bit, and we talked a lot about the centralization, decentralization. I think, Angela, you wrote very important papers about the role of the legal framework and the role of fiduciary duty. Do you want to talk a little bit specifically about permissionless versus permission blockchain?
I don't think you're going to like what I'm having to say very much, but I don't think you've.
That's okay. I like being
let's
offended
talk.
sometimes.
Let's talk. Okay. So it goes exactly with what I was talking about before, trying to find the power in these systems. I focused mostly on permissionless systems, and looking hard at Bitcoin, I do think that these core developers function very much as, I call them fiduciaries of those who rely on these systems.
How are they fiduciaries?
They're fiduciaries in that you have to repose large amounts of trust in them to make good decisions, both that they are competent, that they are doing the right thing as technically, and they know how to code, and they understand the cryptography and the whole system. And my understanding from watching these is that there are really very few people in the world who understand these systems at the level that is required to make these high-level decisions about them.
Well, do you agree that the code is open source?
I absolutely agree that the code is open source.
So in principle, you could go and learn it if you wanted to.
In principle, and that may be okay. I think that we're coming to a place where we're going to realize that open source in the context of systems that are not, socially critical, infrastructural, financial, monetary, is one thing. But once you cross over to a system that seeks to be money, seeks to embed value in it, does critical things for society, and anyone who has money sitting in Bitcoin on these systems is reliant on that system continuing to exist and to run properly. So if people screw around with the code and don't know what they're doing, that's a problem. Okay? And you are not necessarily going to, and just because it's open source doesn't mean that if the goal is to get massive adoption, right, for hyper-Bitcoinization to happen and normal people to be using these things, then I guarantee you, I'm not going to understand how the code works. 90% of the public is not going to, more than that, is not going to understand how the code works. So just saying it's open source is not an out.
So you're saying that core developers have a fiduciary duty to the holders of Bitcoin, or
to the holders of Bitcoin, but to the system, yeah. And it's not just necessarily the holders. It's complicated, and this all needs to be discussed. But it's not just holders of Bitcoin who are relying on them doing the right thing. It's all the businesses who have built on the system. And then it's also all these financial institutional investors who are making financial products, integrating these crypto assets at the base, like Bitcoin, with Bitcoin futures, ETFs, all that stuff that's envisaged. All of that huge ecosystem, I think, ultimately comes down to good decisions by these small number of people okay? And we're trusting them not only to be competent, but we're trusting them to be ethical, to not lie about what they're doing, to not privilege their friends who are a certain minor, right? To not insider trade by doing a shorting Bitcoin when they hear about the bug, and then, right? They get information that they don't necessarily share with everyone.
Sure.
So anyway, I don't think I guess my big statement here is that we wish in these systems, these permissionless systems, that we've escaped the need to trust in others and that there's no power exercised and hooray, hooray. But we haven't, it's just shifted. It's just shifted to another small group of people. And I think we're going to want those small group of people to owe us something.
Right. All right. So first of all, no one is forcing you to run any software. Okay, the open source software has an MIT, Bitcoin has an MIT license. If you look at the MIT license, it says it comes with no warranty whatsoever. You run this software at your own risk.
And that's fine.
No one, there is absolutely, and it says we are not liable for anything that happens if you are running this software. So when you say that core developers have some sort of fiduciary duty, I suggest you look at the licensing agreement under which you are running that software. If you are running that software and not agreeing to it, then don't run that software. Run something else. There's a lot of other software, including ones created by companies where they might give you guarantees, right? Like the Coinbase wallet, for example, they will, if you deposit money to a Coinbase wallet, they might say, okay, well, if it's our fault, then we'll make you whole. And in fact, they have done that when they screwed up with some market-making software that went awry, and somebody bought Ethereum for like 15 cents or something like that when it was at 300, right? Like if you want those sort of guarantees, you're going to have to run different software. But the open source software is very clear. It says there are no guarantees, okay? And you cannot sue them for liabilities. And that's something that you agreed to when you are running that software.
Chris, I'm interested in your opinion because you worked in open source for decades. Right. So do you feel you have, if you write an open source?
I'm not necessarily saying it's every open source project.
So
I'm saying certain ones are different, right?
Okay.
Once we cross the border into things that are potentially critical infrastructure, financial, I think we need to rethink these things. I don't think it's as simple as saying, I can disclaim all liability. So just because I put that in
But that's the only thing that they're working on. The core devs don't control anything other than the core dev repository. That's it.
Laws can be passed. You can change
Chris,
the law.
you can change
the law.
Yeah, you can change the law, but I mean, good luck trying to enforce whatever it is. I mean, you can also pass a law saying like everyone has to swat 30 mosquitoes before you go to bed. And in fact, in China, they did that during like the Great Leap Forward or something. You can pass idiotic laws, but that doesn't change anything, really, if you can't really enforce it. So
Chris,
the open source software is very clear. And that's the only thing the core devs control is that one open source repository.
Yep.
Okay, github.com/Bitcoin/Bitcoin. That's it.
So Chris.
Right. So the license, the MIT license essentially is exactly what you described. It just means basically, as is, here you go. It's furniture left by the side of the road. Doesn't give you any guarantees whatsoever. The commitment that if you will, from the core developers is that you're trusting that the core developers are going to stick around and continue to maintain the software, to continue to analyze and resolve critical vulnerabilities that arise, either within the software or within the software on the systems that software is running on, right?
I mean, that's more implicit than anything else.
Like
no
Spectre
guarantees.
and so forth. I don't know what you guys did or didn't do in terms of analyzing the impact of those types of vulnerabilities on the software itself. But so you're making no guarantees. And the whole point, again, that I just tried to describe, maybe not effectively, of why we're doing enterprise blockchain in the context of a permission blockchain system is so that you can add those layers of trust that do, in fact, allow you to sort of have a little bit less risk involved in utilizing the software. So, for instance, we created Hyperledger Fabric under Hyperledger, which is an open governance model. There's, I don't know, 300 odd members of the community. There's a total of like 40 different companies that are contributing to the development of the software, right? There's like 300 plus people that are contributing to the development of the software. So we've created a community that essentially, even if IBM were to walk away, would continue afterwards. So we've eliminated some of the risk. How many core developers are there?
I mean, there's over 500 people that have contributed to Bitcoin.
Yes.
That have contributed. How many are core
access?
developers? How many are like the ones that can make decisions?
Technically, if you've contributed to Bitcoin Core, you are a core developer. But as far as the maintainers, the ones that are allowed to
So
merge,
let's call them
there's
maintainer.
4 of them.
Okay, 4. So if those 4 people happen to go to the same party and all get hit by a bus,
Then you would have
anarchy.
You would. I mean, I'm sure the ones with the best reputation would.
You'd have total anarchy, right?
Well, I mean, this is what every open source software goes through.
No,
which
but
is
that's
that,
what I
hey,
just
you know,
described.
based on a meritocracy, whoever seems pretty good, they're the ones that have contributed for a long time. They're the ones that end up being the maintainers, or whoever happens to have the right personality for it. The people that are good at examining stuff and figuring out.
Who chooses them?
Usually it's done via IRC. You know, here's
No. I mean, all 4 of the 4 maintainers.
I think
basically
there's
all
about
get
40
hit by
to
a
50
bus.
that contribute regularly. I believe those are the people that have the most say in who becomes a maintainer.
You believe? Is it written down anywhere? Is there an actual approach to what happens if the 4 maintainers get?
No, I mean, again, you're
So there's
free to
risk.
fork at any time and make your own project.
But that's my point. There's risk. There's risk in that system.
There's risk there, and it's different. And I understand that that's the open source model, and it works very well, perhaps, in less critical systems.
I think it's worked very well with Bitcoin.
Well, it can work, I think, if Bitcoin remains a small walled garden.
Right.
But once you start to integrate it into the financial system, and suddenly, even if I'm not investing in something that includes Bitcoin as a base asset, I can be affected because look at what we're doing with the whole new DeFi concept, right? And it's rapidly being built, this decentralized, which I think that's a complete misnomer here, this decentralized financial system. And we're weaving it into everything that we do. So that is the way that it can affect others who did not, click through the open source software license or anything like that. It's systemic in a way that
So there
it's
are other
problematic for just, you're on your own.
right.
Well, if someone chooses to build on something and then blame the thing that it's building on for not doing what it wants, that's kind of their problem, not Bitcoin's, right? Like if you're building on top of some cliff that you think might collapse sometime, then that's kind of your own fault.
Well, we're all being maybe not thinking
Right.
deeply enough about what we're actually doing.
So
Well, I mean that's those corporations' fault, not Bitcoin's.
No,
like Bitcoin's building what it's building.
So, but let's be clear. Again, the whole point of permission blockchain, enterprise blockchain, is to focus on reducing risk, on essentially mitigating risk. And what you're describing is a system that's full of risk. Actually, there is no, I mean, so let's just take the example of the poor.
What do you mean by risk, by the way?
Jimmy, let me make my point. So we recently had an incident where an exchange in Canada, the CEO of that exchange was the only individual who happened to have the private keys to all of the squirreled away Bitcoin and Ether, right? He dies, so do the keys. All of that just evaporates overnight.
Yep.
Totally unregulated. Those people,
okay, right. So you're talking, that's not Bitcoin. That's a centralized company that did
yes,
that.
exactly. The only way that you can actually do anything with Bitcoin is if you go through an exchange and have it exchanged for something.
No, I keep my own keys. I have my own Bitcoin, and most people. Here's the saying from Bitcoin: not your keys, not your Bitcoin.
How do you get dollars out of that?
You don't need dollars if you're transacting in Bitcoin.
If you're transacting in Bitcoin, that's right.
Do you pay your rent? I'm just curious. Do you live on Bitcoin? Do you pay your rent?
No, I have dollars that I use for all of that. But I mean, like, ultimately, what I want to do is transact in Bitcoin when I need to.
Ultimately, right. But again, that presumes that we can develop an entire economy around.
Well, that's what I'm betting on, yeah. And that's my right to do that. And if you don't believe in that, then please don't buy Bitcoin.
Isn't there risk involved in betting? I think that's the whole point.
Well, I mean, do you want to lead a riskless life? Yeah, go for it. I'm fine with the risk that I'm taking, and I think I know enough about the technology to say, okay, well, the risk that I'm taking is appropriate, and I think there's a gap in the market.
The whole point of fiduciary responsibility, and you just said that there's a fiduciary responsibility at the minute.
I didn't say that. She did. I don't think there's any fiduciary responsibility by the core developers because the open source software specifically says it doesn't. If you want, want to use somebody with fiduciary responsibility, then you put it on an exchange where the, like the founder might have the only keys and might die in India, supposedly of complications of Crohn's disease without anyone seeing the body, right? Like whatever happens, that might happen. Like there's all sorts of exit scams that have happened in our industry for that reason. That's why I don't trust any of those. I keep my own keys. I have my own Bitcoin. That means real self-sovereignty. That means real decentralization. So, what you're describing is a very centralized system. Yeah, you reduce risk for a particular set of government regulations or something like that, but it's a very different thing. I personally like self-sovereignty. And I like controlling my own keys, controlling my own money, being my own bank. Instead of having somebody being able to say, that's not yours anymore because we don't like you and we think you're a political enemy.
So let me ask you this. So you're a very smart guy, right? You're clearly very sophisticated about this technology. You're maintaining your own keys, your own wallet and so forth. How many people on this planet are like you? I mean, are there billions?
Okay, so how many people were on the internet in 1992? I mean, like, it's a technology. As the user experience gets better and easier, of course, more people are going to do it. But I can tell you right now, there's a lot of people that do control their own keys, that keep it on a hardware wallet, that keep it on a paper wallet, that keep it on Wasabi wallet or Samurai wallet. There's a lot of different wallets.
There's a lot of people, but seriously, how many people are as sophisticated as you that they could do that?
I don't think it's that sophisticated. A Trezor is not that hard to use.
My point, Jimmy, is that they're going to farm that out to an exchange or to some other
And they'll learn an expensive lesson if that exchange goes belly up, like they did with Mt. Gox, with BitInstant, with Bitfloor, with Quadriga.
You're describing a system that
not your keys, not your Bitcoin, not self-sovereign. You're using a centralized service to take care of your decentralized asset. It ends up being centralized, right? This is why it's not a spectrum, right? It's either 1 or 0. You either control your own coin or you don't.
I would like to, so we have 7 more minutes before the panel is finished. So I would like to spend maybe 5 minutes just a closing statement about the future of permission blockchain and permissionless blockchain. So I would like to start with you, Chris.
Sure.
Like, what do you see is the future of permission blockchain? Where do you see it going 5 years from now? I'm going to ask Angela and Jimmy the same question about permissionless.
So I actually see that there's room for both. I don't actually have an issue with Bitcoin. I mean, this was a nice discussion, nice little argument here, but I'm not. I don't have a problem necessarily with it per se, but you have to understand what a truly permissionless blockchain is, like Bitcoin, and there's risk. There's a significant amount of risk, and you have to be very sophisticated about mitigating that risk. That's my point. So, in the context of trying to take that technology, in the abstract, the notion of a sequence of blocks that are cryptographically bound to the previous ones and so forth, established through consensus, and leveraging that essentially to deliver a much more effective means of distributing information amongst a set of potentially what's the word I'm looking for? Potentially competitive entities, potentially adversarial entities, but in a way that you can trust that the data is correct, all right? We feel that a permission blockchain is the way that you can achieve that in a way that also enables you to achieve consensus and confirmation finality much more efficiently than you can with a truly permissionless blockchain, whether that's Bitcoin or whether that's Ethereum and what have you. And again, now if you want to say that it's a centralized system, there is a certain amount of centralization that goes on. But again, I'm making the argument, I'm making the case that you don't want total anarchy, that in fact, most people would rather have a situation where if they did work with an exchange, that there was some sort of regulation in place that said, if somehow or other, you were hacked, or if there was a bug in the system that caused you to lose, that you'll be made whole. Because that's essentially what happens. You enter into a banking system that's got FDIC, backing of it. That means the government is saying, look, if the bank folds, you're still going to get 100,000 or 250, whatever it is this week, out of that system. And then you can spread your money around to different banks so that you can essentially not lose any money, right? So again, the whole point there is risk mitigation. And you're saying, no, risk is good. And total anarchy is good. And I'm saying...
So looking at the future, how do you see, like 5 years from now, do you see more permission blockchain be
yes.
more the dominant
I wouldn't say a dominant... Again, I think there are a lot of use cases where permissioned blockchain makes a ton of sense. I also tend to think that there's a ton of use cases where permissioned blockchain doesn't make any sense. And in fact, to Jimmy's point, a centralized database is a much more efficient and effective answer to that. And I think over time, a lot of people are going to figure out which side of the balance sheet, if you will, you're on, whether it's an effective use case or an ineffective use case. And I think that, as with any technology, it'll find its way. I think, if I look 5 years in the future, I think we'll have a better understanding of how to address privacy and confidentiality in the context of blockchain. This is something that you can't just deal with encryption, right? It's much more than that.
I want to make sure that also everybody...
I think what I'm saying is that there will be some innovation that occurs that essentially allows us to do this much more effectively.
Angela?
Sure. So on the permission side, I didn't say much about those today, but I'm probably kind of in Jimmy's camp on this, that it's weird to me that we call them the same thing, and I think they have completely different capabilities, and we're still figuring out use cases for the permissioned ones. I'm not sure what they will actually be, so I guess 5 years down the road, I do feel like there's a whole lot of labeling things blockchain just to get people to buy in, and I'm really worried that policymakers are getting a whole lot of that from, blockchain evangelists. And when Kevin McCarthy, I think, gave a speech, I just saw this on CoinDesk, that Kevin McCarthy gave a speech saying, we need to use blockchain for our legislation. So I don't know what that means. I don't know what problems that's solving. I don't
more
think
blockchain.
I agree. Yeah. So I'm really skeptical there. On the permissionless side, I understand the drivers, and I get that in this world where all of our institutions feel like they're collapsing and we don't know who has alliances with who, that trying to create another place to have value in a community that is independent of this sovereign system that in some ways feels like is falling apart, I get that. And I get the discussion and the longing to have kind of a recreation of the internet, except this time we're going to do it right. And we're not going to have the creation of these very powerful centralized entities like we have now with our platforms. And we're like, what did we do? But we are missing stuff. We are missing these concentrated power pockets. And my thought is in 5 years, if we don't wake up and notice them and notice what the miners are doing, these are not peer-to-peer systems. You don't get a transaction onto the Bitcoin blockchain unless the miners process it for you. If the miners are in control, it ain't going there. You can say it's peer-to-peer all you want, but you have to go through the miners to get it on the ledger. Anyway, okay, I'll stop.
Jimmy.
All right, so first of all, if you are a quote-unquote permissioned blockchain, you do reduce risk, but the same centralized entity that reduces the risk can take the thing away from you, right? It's two sides of the same coin. You either have self-sovereignty and you have all of the personal responsibility, or somebody else has that responsibility, but they also have the power to take it away from you. You can't have somebody else bails you out whenever you want and also have self-sovereignty. That's not how things work. You either have self-sovereignty and all the responsibility, or somebody else has it. There's good ways to do both, and there's probably room for both. But like if you're going to go in that direction, blockchain doesn't make any sense at all. Now, I will say that blockchain, not Bitcoin, is a meme that's been going around for like at least 5 years. And 5 years from now, I expect it to be the same as 5 years ago, right? Like people talking about it in some hype manner, but it's really more or less a buzzword without anything actually behind it. And 5 years from now, we'll discover that the last 5 years haven't done anything in that regard at all. Really, blockchain is really useful for Bitcoin. And that's the real use case for it. It allows you to be self-sovereign over your own money. Everything else has a centralized point of failure. That means that somebody can take it away. You're not sovereign over your own money because there's either consortium, some government, some creator, some dev team that controls hard forks or something like that. They're the ones that are really in control. The only one that isn't like that is Bitcoin, and that's what makes it special. That's what makes it interesting.
Thank you, Jimmy. So today you have witnessed a very different opinion about blockchain, specifically about the present and the future of permission versus permissionless. I feel that one of the dangers in our society today is confirmation bias, where people just look for information that actually confirm what they already know. So I think it was important for us to actually have very different voices so that you can actually maybe learn something different from your preconceived view about either permissioned or permissionless. So I thank you very much for the panelists for this engaging discussion.